All right, happy afternoon / evening. Hope everyone's doing well. 412, how many equations do I need? One equations or two. In the previous lesson, you created one or two mathematical sentences that represented word problems, and that was Monday in class, okay? Must start in Monday, okay? Today, you will represent a word problem with two equations. You will also explore how to use the equal values method to solve systems containing equations that are not in y equals mx plus b form. Okay, so we're continuing the process we started last or this week, and this is the next problem. Okay, problem 420, one equation or two. Elsie took all of her cans and bottles from home to the recycling plant. The number of cans was one more than 4 times the number of bottles. She earned 12 cents for each bottle and 10 cents for each can, and ended up earning $2.18 in all. How many cans and bottles did she recycle? First of all, you don't get 10 cents per can. That's a crazy amount, but or 12 cents per bottle. And getting $2.18, man, she should have saved up some more money before going, or saved up some more cans and bottles before going. So practicality aside, let's move on. Solomon decided to solve the problem by writing one equation. He said, I can let B represent the number of bottles, then 4B plus 1 would be the number of cans. 4b plus 1, where did you get that from? Well, I'll get to that in just a second. My equation would be 12b plus 10 times the quantity of 4b plus 1 equals 218. Marcus agreed with Solomon's answer, but said, it is easier to solve this problem with two equations. I can let B represent the number of bottles and C represent the number of cans. That way, my two equations are C, the number of cans, equals 4b plus 1, and 12b plus 10c equals 218. Okay, so what I want you to do is I want you to now write down both parts of these equations. Okay, so we're going to write down, because it says, question A says, Solomon's equation has three terms, 12b, 10 times 4b plus 1, and 218. What do each of these terms represent in the problem? So on your paper, please write down Solomon's equation. Okay, and what I want you to do is I want you to actually tell me, probably above, it's probably easier if we write it from above. Above it, what does each part of these represent? Okay, what do all three of those parts represent? Okay, and we're going to do the same thing with Marcus. Okay, so, all right, so pause, tell me what the 12b is, the 10 times the quantity of 4b plus 1, and the 218. Then when you got that, go ahead and pause. Okay, so hopefully you've got this and you've got the information that this is the money, the cost for each bottle. He got 12 cents per bottle, okay? 12 cents per bottle, and that's what it indicates there. This is 10 cents per can, but this right here is referring to the number of cans. So it's kind of a two-parter there, okay? So the 10 is the 10 cents per can, and the 4b plus 1 is the number of cans. And the 218 is the total cents earned. So since this is in cents, not in dollars, they changed the dollars to 218, changed it to the total number of cents, which made it a little bit easier to work with, okay? Now we're going to do the same thing here. What do each of these parts represent? What does this part, what is this part, and this part? I know it's kind of weird, but it's like, okay? This is the number of cans, 4 times the number of bottles plus 1. 12b is at 12 cents per bottle. This here, 10c was 10 cents per can. And again, here is the total cents earned. All right, I know it's kind of weird, but you've got to be able to identify and place all those values there, okay? All right, next question. Do Solomon's equations and Marcus' equations represent the same problem? Why or why not? Well, hopefully it does. We're just going to kind of summarize here. Hopefully you notice they're pretty much the same thing. Basically, they just replace the C with the value of C, which is the same thing that you see going on up here. Okay? All right. Now that's kind of tricky, but here's what we're going to do now. Oh, that's weird. Okay. Next question. I actually want you to go ahead and solve it. okay? So what you're gonna do now is you're gonna go ahead and solve that problem and tell me how many cans and how many bottles were there, okay? So solve it. So pause it, write it down, show your work, and when you got it, please go ahead and unpause it so I can check it. All right, here we go. Here's the process you should have had. Hopefully you got this. The 12B stays the same. Plus, over here, we're going to distribute. So you should have gotten 40B plus 10 equals 218. I can combine these two and get my 52B plus 10 equals 218. 218, that was horrible. And then do minus 10 on both sides, and I get 52B equals 208. And divide by 52, divide by 52, and I get the B equals 4. So there are 4 bottles. Now, that's not the end of my problem, because I need bottles are 4, but I also need to know the number of cans. So to figure out the number of cans, I kind of am going to take the example from Marcus and use his equation down here to figure out the number of cans, because I do need that information. And cans was 4B plus 1. So if I do that and take, hey, 4 times the bottles was 4 plus 1, C equals 16 plus 1, so C equals 17. So my final answer here, is bottles, there are 4 bottles, and cans, there were 17. This right here is my official answer for this problem. Got it? All right, well, tomorrow when you come to class, we're going to pick up from there. We're going to use some of this basic concept that we're talking about here and just practice solving some of these, okay? So that is it for today. That's all you had to see. Hopefully that made sense, and we'll go from there.